Good morning, or good afternoon, or good night. Yep, all of the above, whatever time of day you are watching this video. Hello. I want you to first take a pause this video, and see which problems you can accomplish on your own. Day 4 is a build off of day 3. They're the same kind of idea. I did want to just try a couple of these problems with you, show you some tips and tricks if you were struggling on day 3. But I do want you to first pause, try all that you can, and then we'll go through them together. So hopefully you did that. We're going to go through these now, and you can kind of correct your work. So number 1 says find the area. Notice this is not a right triangle. So I'm going to use my formula for any triangle finding the area, which is going to be 1/2 A, or the side that makes the angle, times B, which is the other side that makes the angle, times the sine of the degree in the middle, which means it's going to be 3 times sine of 30 degrees, 1/2. So I know that my area of this triangle is about 3/2, or if you prefer 1.5, and don't forget inches squared. Number 2, you will actually see this problem in day 4 assignment. So as we go through it now in this video, you'll at least already have a step up in the problem in the homework. The one thing we have to realize in this picture is that these two lines here are going to be parallel. We know that because there's a nice fact that says if two lines are perpendicular to another line, notice these right angles, perpendicular, then those two lines are parallel. Throwing some geometry stuff back at you. So since those two lines are parallel, I'm going to erase that. This could be what's called the transversal. AC, the transversal. It's the line that is going through two parallel lines, and we get a lot of angle pairs. So I'm going to throw some terms at you. Corresponding angles, consecutive interior, alternate exterior. Hopefully those sound at least familiar. So we're going to use a little bit of geometry. So I'm going to erase these lines just so that we can see what's happening. So what I'm really telling you here, I'm going to zoom into my picture a little bit more. This angle right here, theta, is corresponding to this angle here, theta. I'll write what that is. So these are the corresponding angles. Oops. Because you have those parallel lines. Parallel is usually noted with a little arrow. So I'm going to put those are parallel lines. So corresponding angles are congruent. So they're both going to be named theta. If you couldn't get that step, then the rest would be a little tough. So this might be anything you needed to now finish the problem on your own. So figure out where that is for you. If you do need a little more assistance, let's go through it together. We're going to find BC, express each of the following lengths as a function of theta. That means our answer is going to have theta in it, and don't be concerned. My first side is BC. So BC is right here. I'm going to use the fact that I have a nice right triangle right here with theta. Opposite side is length 5, and we're finding the hypotenuse. So hopefully seeing all of that, you're thinking SOHCAHTOA, opposite over hypotenuse. I'll even write out SOHCAHTOA again. We have the opposite and the hypotenuse. So that tells you we're going to be using sine. So sine of my theta, that angle of focus, equals my opposite over what I'm finding, BC. That's the length I'm finding. To solve this, just like the day before, I'm going to put this over 1. BC times sine of theta equals 5. I want BC, so I'm going to divide both sides by sine theta, which leaves me with BC equals 5 over sine theta. Yes, that looks weird, but we did what it asked. We got BC in terms of theta. That's what we have to do. Now we're going to find AB. So I'm going to erase what we have, erase all that. Let's start fresh. I want AB, which is right here. Looks like we have a new triangle of focus right here. We always have to find that right triangle in order to use SOHCAHTOA. Angle of focus is theta. I know the adjacent side is 4, and we're searching for that hypotenuse. SOHCAHTOA, that's telling me I'm going to use cosine this time. So cosine of theta is going to equal my adjacent side of 4 over what I'm solving for, AB. Put this over 1, cross multiply. You'll see we do the same pattern pretty much over and over. We're solving for AB, which would be 4 over cosine of theta. Now I'm going to erase everything we had on here so we don't get confused. The last thing I want to find is AC. AC is this entire length. So I have this big right triangle to look at. But sadly, I don't know either leg of this right triangle. So if I wanted to do the same steps I did for A and B, it's going to take me a lot longer. But do you notice that AC is equivalent to adding the AB part to the BC part, which those are the two lengths I just found. I can use that to my benefit. AB is 4 over cosine theta, and BC is 5 over sine theta. I know it looks weird, I know they're not common denominators, but feel free to leave it just like that because you found AC in terms of theta. Now I mentioned before, this problem is in the day 4 homework. So please make sure you copy that over into your homework, and that problem is now completed for you. We're going to do some finding area. This should be review, many ways to do it. First thing I'm going to do is figure out, I'm going to zoom a little bit. Oh, sorry. We're going to look at the fact that you can make a circle around this if you want. The circle around it is 360 degrees, and we're going to divide it by the number of triangles we have. Well, this is 1, 2, 3, 4, 5, 6, 7, 8 sides, so I can really make 8 triangles. It's an octagon. So here are my 8 triangles. So if I divide by my 8 triangles, I'll see that each angle in the center is 45 degrees. So this would be 45 degrees, so forth, so on. All of these are 45 degrees. I'm trying to use my formula that we did in problem 1/2 AB sine theta, but I actually don't know the side lengths. I don't know what A and what B is. So I'm not going to use that route. We actually have to go a little bit deeper to find that side. Hence, this is why it's on day 4. So what I'm going to demonstrate to you guys right now is, yes, each angle of focus is 45 degrees. But if I want to just look at this triangle right here, it's going to be a right triangle, and it will help me find a side length that will be my A value to find the area of the big triangle. The angle in here, which I'm just going to redraw this out here, my dear, so we can see what's happening. This is that right there just blown up. This is going to be X. We're going to solve for it. This angle is going to be 45 degrees divided by 2. So 22.5 degrees. Again, you're like, well, this isn't that helpful yet. I still have too many unknowns. But this side right here is labeled as 8. I'm telling you, this is a regular octagon. So I actually should write that out. Okay, regular means equilateral, equiangular. So if this length's 8, this is 8, this whole thing is 8, which makes this 4 because it's half of 8. I know this is a lot of extra, but this is helping us to find this area of the triangle, and then I can keep multiplying. So if I want to find x, notice I have the opposite and hypotenuse. So you should be thinking of sine of my angle equals the opposite over hypotenuse over 1, cross multiply, divide both sides by sine of 22.5. You're in degree mode on your calculator, so you should get x to be about 10.45. If you didn't get that, please make sure you ask in class. It is a calculator issue that needs to be resolved. This is telling us that this x is 10.45. That every length from the center to the edge is going to be 10.45. Right? That's the radius of the circle. Now I can use my fact of area of any triangle. Area equals 1/2 A, which is the 10.45, times B, which is also 10.45. Running out of room. It's actually still not going to be enough room. There we go. Sine of the angle in the middle. Well, look at it, my dears. I just made this triangle. I'll change the color, keep it fresh. This right here. Both sides are 10.45. The angle of focus is 45 degrees. So we did all that work because we needed to find the A and B. When you simplify, you'll get 54.6 sine of 45. You should know it. Root 2 over 2. Simplify, I'm getting about 38.61. Please make sure you can get that. That's for one triangle. Keep in mind, there's 8 of them. So the grand total would be 308.87 units squared. If you find a different way to solve this, perfectly fine. I know some of you might find just the area of this yellow triangle, and in that case multiply by 16 because there's 16 of the yellow triangles, or there is 8 of the green triangles. Up to you. Last problem, you should have seen something like this in geometry. Area of the shaded region. So that means you're going to take the circle area and subtract the polygon. It will give you the black shaded area. So using this formula, so area of the shaded will equal area of the circle minus area of the polygon. Quick reminder, area of circle is pi r squared. The radius, which is dictated right here, center to edge of circle, is given as 4. So this is 16 pi. Area of a polygon, a little bit more steps, but we should be feeling good about that now. Area of the polygon is going to be 1/2 my AB sine of theta. Okay, well, here is my triangle. realize I can make 6 of them, which means I'm going to take 360 degrees divided by those 6 triangles. Each angle of focus is going to be 60 degrees. Each radius is 4. That's true about a circle. So using my formula, A is 4, B is 4, and I'm finding sine of the angle of focus is 60 degrees. Here you'll get 8 times sine of 60, root 3 over 2, which gives you 4 root 3. But wait, this is just the area of one triangle. That's just of this triangle right here. Don't be that silly goose that forgets that you have to multiply by 6 triangles. So the area of the polygon is really 24 root 3. Subtract that away from your circle. So that's taking the big, taking out the middle part, the area of the shaded is 16 pi minus 24 root 3 units squared if it's asking for exact. If it wants approximate, it's about 8.70 units. Please confirm that you can get that value by plugging in 16 using the pi button, which is second, the little caret button above the division. If you need help, please let me know. Minus 24 root 3. This, my dears, will help you with day 4 and maybe clear up some issues from day 3. If you have further questions, please make sure you're asking. A lot of this comes from geometry. So if you haven't taken geometry for a while or just need a little recap, I am here and we will get through it together. Have a great day.